completed. Today the topic of discussion is multi-threading. Multi-threading. Okay. Now let's consider that there is a very big factory. Okay. In the factory, what we are doing is we are constructing these motorbikes. Okay. Let's consider like if there is a motorcycle factory is there, then do we construct all the parts at the same place, like tires, handles, engine, or tubes, or some other thing, screws? Do we construct all the things at the same place? No, right? Now, what happens is let's consider that I have tires, engine, tubes, wheels, and let's consider basic parts of motorcycle. Then what I'm doing is let's consider like a process comes here. Okay, and just first tubes will be constructed, and then tires will be constructed, and then engines will be constructed, and wheels will be constructed, and engine will be constructed, and seat is constructed. Okay, then if the whole process is constructed as a single unit, if the whole process is constructed as a single unit, or if the whole bike is constructed as a single process, what happens? Okay, only one bike can go through the left side. Okay, until one bike is completely constructed. Until one bike is completely constructed, we cannot go with the second one. But is it a correct process to follow? Is it a correct thing? If we follow this approach, what happens? We cannot get correct results. We cannot make the maximum use of the productivity. So what we need to do? We need to make it a separate units. This is a separate unit. Tires is a separate unit. And engines is a separate unit. Wheels are a separate unit. Handle is a separate unit. And seat is a separate process. Okay? We make them as separate processes, and we make, okay, we have a process manager which manages all the processes. Okay? So first it will make a order to tires, make a order to all the units. Okay? And we get the output from all the units, and it will send them to assembly point. Okay? Where we assemble them. So each and every process is considered to be individual unit. Okay? Each and every specific part is constructed as an individual process, and they are assembled to this. Now, which approach gives you a better result? The first one or the second one? Definitely the second one will give you the better result. This is nothing but, okay, multitasking. Okay? Performing multiple tasks at the same time. Parallelly, tires are constructed, something is constructed, wheels are constructed, handle is constructed, and engine is constructed. multiple tasks are performed at the same time. Okay? This is nothing but multitasking. Okay? Just in order to achieve this kind of multitasking. Multitasking means performing multiple tasks at the same time. In order to perform multiple tasks, we have different approaches, okay, to perform multiple tasks at the same time. Okay? Let's take another example that in my working system, I have opened Netflix, I have opened something else, okay, I have opened folder, I am listening to music, okay, and I have started downloading a software. Let's consider I'm listening to music, my sound is for some 5 minutes. Okay, just now I have started the song. After 5 minutes, the song will be ended. After 5 minutes of my song is ended, is still the downloading percentage is 0 or will it be increased? See, if I am listening to a song that takes 5 minutes, within that 5 minutes the downloading percentage from the internet will be increased or will it be the same? It will be increased, right? That means I am listening to music. That means that is a task. As well as downloading is continuing, that is also a task. If you make some copies, it will also be continuing, that is also a task. But how are the CPUs different or the same? But how the same CPU can perform all these tasks? Okay? It's not possible, right? A CPU can perform only one task at a time. But how this CPU can perform at a time, multiple tasks at a time means, okay? If you see, we have task manager. Okay? Most probably we have used this task manager only to break the tasks that are hanged. But this has much meaning. Okay? This task manager is the thing that manages the tasks, that manages the processes. Okay? There might be multiple processes in the same processor. There might be multiple processes running in the same processor. If we run multiple processes, like say copying is one process, downloading is one process, listening to music is one process, playing a video is another process. Okay? How these multiple processes are processed? How these multiple processes are processed at the same time by a single processor means it's not the case. Okay? Multiple processes cannot be processed by a single processor at the same time. At one time, only one process will be processed. But what happens is inter-process conversion. Okay? Let's consider like I have three processes. First one is copying, second downloading, third one is playing the music player. Okay? If we have three processes like this, then what happens is, while creating the process itself, this task manager, what it will do means, it will give some CPU time. It will give some CPU time. It will give some time to that process. The time is called as CPU time. And the CPU time will be in milliseconds. For any process, the CPU will give you CPU time. Okay? Let's consider like the CPU time for copying is 10 milliseconds. For downloading it is 15 milliseconds. For music player it is 7 milliseconds. Let's consider like the CPU time for copying is 10 milliseconds, downloading is 15. Okay? And listening music is 7 milliseconds. Then what happens is, for 10 milliseconds, okay, let's consider like for 10 milliseconds the processor will process the copying task. Okay, after 10 milliseconds, then it will process the downloading task, and then for 7 milliseconds it will process the music playing task. But the processing time is very minute, very less, so that we cannot recognize that. See, within if the music is broken for 7 milliseconds, can we recognize that? No. So, but it will be broken for some time, but it is not recognizable by the human eye. Okay? It's like that. It's the process management in computers will be like that. It will be performing multiple tasks at the same time, but through multiple processes. Okay? Anyway, if you want to achieve multitasking, okay, we can use multiprocessing. But what happens in real time is, while converting from one process to another process, it takes some time. Process to process conversion will take some time. Okay? So, to avoid the time losses because of process to process conversion, okay, a new mechanism has invented, which is multi-threading. Okay, the achieving this multitasking using processes is called as multi-processing, and achieving this multitasking using threads is called as multi-threading. Achieving the multitasking using threads is called as multi-threading, and achieving multitasking using processes is called as multiprocessing. What is the disadvantage of multiprocessing is the process to process conversion time. But a thread to thread conversion time is very less when compared to process conversion time. Thread to thread conversion time is very less when compared to process conversion time. And at the same time, we can apply better levels of security at the thread. At the same time, we can apply better levels of security at the thread. So, why we go for multi-threading? Why we go for multi-threading is to achieve multitasking. Okay? To achieve multitasking, to achieve multiple tasks, or to perform multiple tasks at the same time, we go for multi-threading. But for doing the same task, we have multiprocessing. Why I should go for multi-threading means the performance of multi-threading will be far better when compared to multiprocessing, and we can apply better security levels in multi-threading than multiprocessing. We can apply better security levels in multi-threading than multiprocessing. The whole Java development will be based on threads. Whatever we execute in Java, every execution will be done using a thread only, internally. But how that happens using a thread, that we'll discuss. But in Java, everything is based on threads. Okay? Each and every execution will involve threads. Whether you execute the application from your desktop or you execute the application from your browser, from wherever you execute, every execution will have a threading concept. Okay? Without threads, there will not be any execution in Java. Either you might be executing that application through desktop or through the browser. Okay, how that involves threading, that we'll discuss. Okay, now multi-threading in Java, okay, is achieved using a class named thread. Thread is a class in Java.lang package, and the corresponding interface is runnable. And thread class extends to runnable interface. And the runnable interface contains one abstract method run. Run is the abstract method in runnable interface. Since it is interface, I do not keep any abstract keyword. Okay, if there is a method in a interface, means it will be abstract. Run method is abstract method in runnable interface. And thread class is a concrete class. Thread class implements runnable method. Sorry, thread class implements runnable interface and it overrides the run method. Thread class implements runnable interface, and in thread class already run method is implemented. In thread class already run method is implemented. Along with this run method, which is inherited from runnable interface, the thread class several methods that we'll discuss one by one. Okay. Along with the run method, which is inherited from the runnable interface, thread class has several more methods that we'll discuss one by one. Okay. So thread is a root class and runnable is a root interface for multi-threading. Okay, runnable is the root interface for multi-threading. Now, just let me develop a very new application which demonstrates the threads. Okay. No. Now, why we write a thread means, why do we write a thread? To achieve multitasking. Okay, that means each and every thread should perform a task. Okay. Now, the thread should be assigned with a task. The thread should be assigned with a task. Alright? See, now, where we write the task of a thread. Let me create a simple thread. Okay, which extends to thread. We can create a thread. We can create a user-defined thread. We can create a user-defined thread by extending to thread class. How we can create a thread means we just define a class which extends to thread class. First, we define a class which extends to thread class. And the second step is you override run method. You override run method. In the run method, we write the business logic related to the thread. We write the task related logic to the thread. The business logic related to thread will be written in the run method. Run is a empty method in the thread class, it doesn't have any code. In the thread class run method, it doesn't have any code. So what we do is, if you want to write any business logic related to our thread, we override the run method and write the business logic in the run method. Yes, I am printing some thousand statements here. My business logic is to execute some thousand statements here. And how we can create a thread means, the first thing is write a class which extends with the class, override the run method which contains the thread related business logic or thread related task logic. Okay, and just create an object to the thread class. The next step is create an object to the thread class. Create an object to the thread class. create an object to the thread class. And the next step is execute start method. We told like there are several methods in the thread class other than run. These are not inherited from runnable interface. These are specific to thread. The only method that is inherited from runnable interface to thread class is run. And all these methods are specific to thread class. Hey. All these methods are specific to thread class. Hey. Hey. All these methods are specific to thread class, and there is a method start in the thread class. Okay. Okay, this statement will just create a thread object, but creating a thread will not make it to involve in multi-threading. We should create a thread as well as we should activate a thread. When a thread is active, then only it will participate in multi-threading. Just creation of a thread object will not make it active. In order to make the thread active, we need to execute start method. If you execute start method, then only a thread will become active. Okay? A thread will become active only when you execute start method. If you don't execute start method, it will be like other object. It will be like other Java object. Until we execute start method, even thread will be like other Java objects. So, when a thread object will get a special feature means when you execute start method. When we execute start method, the thread will become active and it will have some special features. Okay, so let me try to compile and execute this application. Where I have saved this? Tutorials, okay. Let me go to this SRC. Sorry, it's a dot. It was compiled. Let me go to the classes. So this run method is being executed for multiple times. Now did I execute the run method from the application? In the application, did I execute run method anywhere? Where is this? In the application, did I execute the run method anywhere? No. The how the run method is executed means the start method. Okay? The start method, last statement of the start method is the calling statement of the corresponding run method. How the start method will be means the start method contains. Okay? The start method contains. It will be like this. It contains all the logic to activate the thread. Okay, it contains the logic to activate the thread, and at the end, last statement is execution of the run method. The very first statement of a start method is the logic to activate the thread. And the last method of last statement of start method is the last statement of start method is execution of run. Execution of run method is the last statement. Okay? Now, so whenever we execute start method, then the run method is also executed. And we should not start the same thread twice. We should activate the same thread only once. We should not start two threads twice. The same thread twice, sorry. We should not start the same thread twice. See, in the middle it gave an exception. That something illegal thread state exception. Okay, why it gave an exception means we have tried to start the same thread twice. Okay, we should not start the same threads twice. If we do so, it will give illegal thread state exception. Illegal thread state exception. Okay, we should start the thread only once. And okay, any statement that is executing in Java will be executed through a thread only. Okay, any statement that is executed in Java will be executed through a thread. So if I execute this statement, it will be executed through a thread. If I execute this statement, this will be executed through a thread. If I execute this statement, even this also will be executed through a thread. But did we create any threads to execute these statements? Did we create any threads to execute these statements? See, to execute these statements, did we create any thread? To execute these statements, did we create a thread? That's what I'm asking. Okay, are we creating a thread for execution of these statements? No, right? But how these statements are executed? I told that each and every statement in Java will be executed through a thread. But if you are not creating a thread to execute these statements, from where the thread is being created? Means while executing the Java command for standalone application, while executing the Java command, okay, the JVM itself will create a thread. Okay, if you want to execute the Java command, okay, successfully, what do we need to do? We need to have dot class file. We need to have a main method. Okay, so the execution will be initiated from the main method. Okay, so the JVM, what it will do means the JVM will create a thread. Okay, and the purpose of the thread is to execute the main method. Okay, and that thread is called as main thread. Okay, and while executing the Java command, the JVM will create a thread. And the purpose or the task of the thread is to execute the main method. So the thread is called as main thread. The thread is called as main thread. The thread is called as main thread. Okay, main thread is a thread which is created by the JVM while executing the Java command. While executing the Java command, the JVM executes main thread, or the JVM creates a main thread. And the purpose of the main thread is to execute the main method. Main thread will be created for each and every Java execution. For each and every Java execution, main thread will be created, and the purpose of the main thread is to execute the main method. Okay. Now, how these statements are executed? How these statements are executed? Through main thread, by using the main thread. The main thread will execute these statements. Whatever the statements that are present in the main method, or whatever the blocks that are called from the main method, all those executions will be done through the main thread, which is created by the JVM. Okay. So let's consider, like, if I call start method, even start method is also executed through main thread. Even the start method also is executed through main thread. So whatever the methods that we execute from main method, okay, whatever the statements that we execute from main method, all those statements will be executed through main thread itself. Understood? So how we can come to know? Okay, how we can come to know which thread is currently executed? I don't know which thread is executing these statements. If you want to know which thread is executing this statement, okay, there is a method in the thread class which is a static method current thread. In the thread class we have a method current thread. Current thread will return a thread class object. This will return a thread class object, not a thread class object, a thread object. This will return a thread object. Current thread will return a thread object which represents the currently executing thread. This will return the currently executing thread. So, just I am giving the currently executing thread. Okay, each and every thread has a ID and name. Okay, each and every thread has ID and name. So ID is the unique property of a thread. Each and every thread object will have two things. One is ID and name. ID is the unique property of a thread. ID is the unique property of a thread. Each and every thread object will have an ID and name which is given by the JVM. Sorry, ID will be given by the JVM and name is also given by the JVM. ID and name will be given by the JVM, but we can change the name but not the ID. Name can be changed but ID cannot be changed. See, by default, the JVM will provide ID and name to a thread. By default, JVM will provide ID and name to a thread. But the ID cannot be changed, but name can be changed. The ID cannot be changed, but name can be changed. Once the thread is created, we can change the name also. But once the thread is created, we cannot change the ID. So, in order to get the name of the thread, we execute get name method. Okay, and for user-defined threads, the JVM will create with this syntax. And so on. Thread-0, thread-1, thread-2, thread-3, like that. For user-defined threads, the JVM will create the name of the thread in this format. For user-defined threads, the JVM will create name of the threads in this format. So, let me see what happens. Which thread is currently executed? Photo classes execute this. Which thread is currently executed? Thread F1 0. That means, is it the main thread or is it any other thread? It's not the main thread. It's not the main thread. It is the user-defined thread created by us. Okay? So, now, what I will do is, I will do the same thing. Even in the main method. I will do the same thing even in the main method. Okay? I will do the same thing even in the main method. Just in the main method also I am executing some thousand statements. Let us see in the main method which thread is active, which thread will be executing the statements. In the main method, which thread is executing the statements? In the main method, which is executing the statements? Main thread. The name of the thread is main. In a main method, all the statements will be executed through main thread. Okay? In the main method, all the statements will be executed through the main thread. See, can we expect the output for the multi-threading? First it is 0, main and 1 main and thread F1 0. Okay? And then main. Okay? At last if we come here, okay, the main thread execution is got over, but still the child thread needs to execute some 25 statements. But are the number of statements in main and child thread are they the same? The number of statements in the for loop of the main thread as well as for loop of the child thread, are they the same? Same or different? Same. But even though they are same, they are not consecutive. Even though the number of statements are the same, the output is not consecutive. Like one main thread, one child thread, one main, one child, one main, one child. It's not like that. Okay? We can never expect the output in case of threads. It depends upon the CPU time. Okay? We told that what CPU time is. Okay? It depends upon the CPU time. So, we can never expect the output in case of threads. So, now, how many threads are there in the application? How many threads are there in the application? 2 threads. One is the main thread and second one is the child thread. Main thread is the thread which is created by the JVM. Okay? This thread, my thread object, I have created in the application. Where I have created in the application? In the main method. Okay, which thread executes the main method? Main thread. So, this my thread object is said to be a child thread to main thread. Main thread is said to be parent and my thread is said to be child. Just because we have created the child thread, this thread object. We have created this thread object through the main thread. This thread object is created through the main thread. Because of execution through the main thread, this thread is created. So this thread is said to be a child thread. Understood? This is said to be a child thread just because this execution is being performed by the main thread. And so main is parent, this is child. Now, if I execute run method, now this run method is executed by the child thread or the main thread. If I execute run method, previously I was executing start method, but now I'm not executing start method, I'm executing run method. If I execute run method, is this execution done through main thread or the child thread? Is this for loop execution? Is this done through main thread or child thread?
Main loop detail is process, not a thread.
Mhm.
Because we are not starting with this thread.
See, main thread is not a process. The execution of main method is done through a thread.
Okay, sir.
No concept of process here.
Okay, we are creating my thread.
Mhm.
Treated as a class and
Mhm.
separate method as run.
Hmm.
So it is executed by the main thread.
See, I have created. You are telling that I have created a thread.
No, you haven't created any thread.
Hmm?
You haven't created. You created, but you are not yet started. So,
See, I have created a thread object, not a thread. A thread object is different and a thread is different. Okay? This we can consider a thread object as a thread only when it is active. We can consider a thread object as a thread only when it is active. But is thread object active now? No. If thread object is not active, then it doesn't have any multi-threading features. It works simply like any Java object. Okay. So now here this is a thread object, that's for sure. But this is not an active thread. An active thread will have multi-threading features, but a simple thread object will not have multi-threading features. Okay? An active thread will have multi-threading features, but a simple thread object will not have multi-threading features. So, for that reason, is it now while at the time of executing run method, is the thread active? Is the thread active? No. Since the thread is not active, okay, what happens is this run method is executed through main thread itself. Just because run method is executed from main method. Just because run method is executed from main method, this run method will be executed through main thread. So now the execution of run method is being done through main thread. Okay, just because the thread is not active. Now,
What is active means because we are calling T1 dot run. So that means we are calling that object only.
just we are calling the method of the thread object. That's it.
So that doesn't
But that doesn't contain. We are calling the run method of the thread object, but that doesn't contain any threading features. See, if a Java object doesn't have threading features, it will behave same like any other object. But a a thread object will have some special features, some special behaviors only when it gets some the threadness features. How to get the threadness features? When the thread is active. How to activate the thread? Execute start method. That means until execution of start method, it doesn't have any special features. Okay? So just if the run method is executed through start method, then only the execution of run method will be in a multi-threaded manner. If the run method is executed through start, then only the execution of run method will be in a multi-threaded manner. If the run method is executed through start method, then only the execution of run method will be in a multi-threaded manner. పెద్ద బుక్స్ పెట్టుకోవచ్చు కదా ఎక్కువ చిన్న బుక్స్ కంటే వచ్చే చూస్తుంది మిస్ అయ్యే ఛాన్సెస్ ఉన్నారు.
Actually, miss అయితే ఒక book పోతుంది, పెద్ద book లో అయితే
Anything has positives and negatives, right? Okay, it's your wish. So now if you execute start method, then at the time of executing run method, is the thread active? At the time of running the executing the run method, is the thread active? Yes, definitely. Just because we have seen that first activation of start method, the start method, first activation of the thread will be there, then execution of run method. So first the thread will become active, and then run method is executed. So thread will become active, and the activated thread will execute the run method. Okay, the thread will become active, and the activated thread will execute the run method. And so here the output is thread-0, just because the activated thread in the start method. See, first what we are doing, we are executing the start method. We are activating the start method. So we are executing the start method. The start method, first what happens, the thread will be activated. So now the run method will be executed through the activated thread, activated child thread. So since the activated child thread is executing the run method, the output is thread-0. It's not main. Now let me make it 2 times. Now, because of first execution, run method will be executed, right? When we execute start, then run method will be executed. Okay? Now, which thread executes that run method?
Main.
See, because of start method, once the run method is here, the run method is executed twice. Once because of the start method. Whenever we call start, then run will be executed. That's one thing. Second is we are explicitly calling run method. Now, in both the cases, okay, is the run method executed by the child thread, or first main thread child thread, or first child thread main thread? Like, what's the output?
And the limit of I is equal to 0. The main thread is good, and for the start also is good.
That's what my question is. If for the first thread see, for start execution, once the run method is executed, right? For run also, run method is executed. That means run method is executed twice. If run method is executed twice, through which thread the run method is executed? Through which thread the run method is executed? See, the run method is executed twice. Once because of start method, and second is because of run method that we are calling explicitly. Okay, the first is through start method. The second is through the explicit call in the age statement. Now, for the first, which thread is executed? Which thread executes the run method? And for the second execution, which thread executes the run method? That's what my question is.
And first one for the method is good, but the next one, the main thread is good.
That's a perfect answer. That's a perfect answer. Okay. For the execution of run method through the 7th statement. See, the 7th statement contains start. Even start will execute the run method. Okay. If the run method is executed through start, then only that execution will be done by the child thread. Otherwise, if run method is executed explicitly, that execution will be done through the main thread only. So, if I execute one run method is executed through main thread, and one run method is executed through child thread. Which run method is executed through child thread means the execution of run method that is done through start. Okay, if the execution of run method is done through start, then only it will be a multi-threaded. Otherwise, if we execute the run method explicitly, it will not be multi-threaded. Understood? It's how it will be. And we can execute run method for n number of times, but it will not be multi-threaded. But we should not execute start method multiple times. We should execute start method only once. If we try to execute start method multiple times, it will give illegal thread set exception. Now, let me start two threads. Okay, I have started two threads. Now, these two threads will have different thread IDs and different thread names. See, first one is thread-0 and the second one is thread-1. Okay, now it is one by one, first, second, first, second, first, second. But we cannot expect the same output for different executions. We cannot expect the output in case of threads. Okay, but in this case it is first, second, first, second, first, second. Okay, thread-1 means the second child thread. Thread-0 means the first child thread. Okay, like that it will be. We can create any number of threads. Okay, we can create any number of threads. For the same thread class, we can create any number of threads. There is no restriction. And the next thing is, okay, a very important thing. Just we'll see what is the life cycle of a thread. Life cycle of a thread object. It's very important for interviews. What's the life cycle of a thread? The life cycle of a thread contains 4 phases.
And if you enter some variable index in the mind thread, some variable in the index of the mind thread, some variable index, then if they use the counter, then any ambiguity
For
if there is some variables actually last mind is there. Here I take some variable index and I some implementation in the monitor and visible and reading and enter that T1 and T2 and 2 are doing concurrently for the same with instruction. So here I am doing the
see, for different objects, the variable will be the same object. Then it will be ambiguity. For different objects, different sets of attributes will be there. Different objects will not share the same attribute. The ambiguity will become when it is a static. Difference will be there. Difference will be ambiguity because multiple threads are accessing the same method and all are changing the values. Okay. multi-threading. Okay, depends upon thread, and this thread has different phases. Okay, the thread life cycle consists of 4 phases. The thread life cycle defines, okay, different phases of the thread. Okay, and the first phase of the thread is newborn. Newborn is the first phase. Okay, when the thread will come into the world stage is just when we create when we create a thread object, then the thread will be there in newborn state. And the thread will be there in newborn state. Now, in the newborn state, will the thread have the threadless features? Multi-threading features will not be there for a thread in a newborn state. Okay? But multi-threading features will be there for a thread in active state. Multi-threading features will be there for a thread in active state. Okay? And how I get bring a thread from newborn to active stage? Execution of start method. By executing start method, we bring a thread from newborn to active stage. This active stage, okay? In this active stage, the thread will have multi-threading features. In this active stage, the thread will have multi-threading features. In the active stage, the thread will have multi-threading features.
Can main thread do not have multi-threading features? Main thread do not have multi-threading features.
Definitely it will go in all the process. But that process is not maintained by us, that process is maintained by the JVM. See, maintenance also will have all these steps, but that is done by the JVM. See, what we are doing for my thread, the same thing is done for main thread by the JVM. Okay? Understood? Now, in the active stage, there are two phases. Running phase, runout phase. In the active stage, there are two phases. One is runout phase and running phase. Okay? All the threads that are waiting for execution will be there in runout phase. Let's consider like T2, T3, T4. All the thread objects that are waiting for execution will be there in runout phase. The thread which is currently executed will be there in running phase. The thread which is currently executing will be there in running phase. Okay? And At maximum, only one thread can be there in running phase. At maximum, only one thread can be there in running phase. So, for us what happens is, it appears that if there are multiple threads are executed parallelly. But at a very minute point, multiple threads are not executed parallelly, but for us they appear to be executed parallelly. But what happens in execution is only one thread will be executed at a time, but the time is very less so that it cannot be recognized. The conversion of thread time is very less so that it cannot be recognized by us. Okay, so one thread will be there, only one thread will be there in the running phase. Okay, and that will be it. Now, how, depending on what factor the threads will go from runnable phase to running phase means, okay, depends upon the parameter. Depends upon the parameter. Okay, let's consider like first T1 comes, T2 comes, and then 3 comes, and then 3, 4 comes. Let's consider like this is the order: T1, T2, T3, T4. Okay, all these 4 are there in the running phase, and all those 4 are waiting for to go to the running phase. Then, on what criteria or on which factor the JVM will send the thread from running phase to running phase means based on the priority. If multiple threads are waiting for or multiple threads are competing for execution, which thread enters the running phase first means the thread which has more priority. Okay? There are 3 levels of priorities in multi-threading. Okay? Minimum, normal, max. These are 3 priorities that are available: minimum, normal, and max. Minimum, normal, maximum. Minimum is this, normal is medium, maximum max. Okay, so let's consider like there are 4 threads and they have different priorities. Okay, then the highly prioritized thread will go first. Let's consider like if all the threads have the same priority. If all the threads have the same priority, then it will be a queue mechanism. First in, first out. Okay? If all the threads have the same priority, then it will be a queue mechanism. First in, first out. So, propagating the threads from runnable phase to running phase depends upon priority. Okay, highly prioritized threads will execute first. Highly prioritized threads will be executed first. And for how much time a thread will be there in the running phase means it depends upon a factor which is CPU time. For how much time a thread will be there in the running phase means that depends upon a factor of a thread which is CPU time. The CPU time determines for how much time the thread will be there in the running phase. There is no relation between CPU time and priority. A thread will high priority, a thread with maximum priority can have less CPU time. A thread with minimum priority can have more CPU time. There is no proportional relationship between priority and CPU time. Priority is just to enter into running phase, that's it. But after entering into running phase, all threads will be there in the running phase as per the CPU time. Okay? The execution of a thread or the execution time of a thread in the running phase will depend upon the CPU time. It doesn't depend upon the priority. Okay, irrespective of the priority, a thread will be there in the running phase only up to the CPU time. Irrespective of the priority, a thread will be there in the running phase only up to the CPU time. Understood? Okay, so the thread, all the threads from new function will come to the runnable phase, and from the runnable phase, when they get the chance, they will go to running. So from running phase, when thread will come back to runnable phase? When a thread will come back from running to runnable phase? Once the CPU time is over. Once the CPU time is over, T1 will come back to the runnable phase, and again next prioritized thread will go to the running phase. Okay? Let's consider P2 is the next prioritized thread. So T2 will go to the running phase. Now T1 will go to the running. So that it will be a cyclic process. It will be a cyclic process, but it is not recognized by the human. But the conversion of a thread from running phase to runnable phase is very much faster when you compare the conversion of this process. If your process is not recognized by us, thread is still not recognized by us. So it appears for us to be performing multitasking at the same time. Okay. Now, let's consider we have IRCTC account where we are looking at ticket order. Now, once we fill up all the ticket details, we should make a payment. Okay. If you are making a payment, then it will ask which one bank do you want to select. I select ICICI Bank and submit. So what happens? The control will go to ICICI. The control will go to ICICI. Let's consider that for IRCTC application, I have opened some 50 threads. 50 threads are opened for IRCTC. Now, it may take 5 seconds or 10 seconds or 15 seconds or even 1000 seconds to get a response from IRCTC. Because based on the application we give, we may or may not get a response. Or sometimes we may get a response late. So, it depends. Like there is dependency for ICICI threads on, for IRCTC threads on ICICI. Just because, see, let's consider we are performing some ticket booking online. So, at one point of time, we need to interact with ICICI Bank. So, what we done is, these threads, 50 threads which are open for 50 threads which are open for IRCTC. Okay? These threads are still active, which is not connected, right? See, some others might be doing another process in IRCTC. 50 threads also will complete it, right? See, I am a user and X is a one user, Y is one user and Z is one user. For this X, Y and Z, 50 threads are over. Total 150 threads will be there. So for X user, what happens is his ticket processing is over. It needs some approval from the bank. That amount is debited from the ICICI to IRS. It's waiting. X is waiting. But still, Y and Z are doing some process in IRS. So for X, he's temporarily doing temporarily X is not doing the operation. But still in the back end, the threads created for X are there. So the threads will be communicating with Y and Z for execution. Now will the performance decrease or not? The performance will be decreased unnecessarily. If X is doing operation, Y is doing operation, and Z is doing operation in IRC, the performance this means it is acceptable just because multiple users are using the application. But here, even if X is not using X, related threads are completing for the CPU time, for the running phase, which is not correct. So, whenever the threads are not useful for particular span of time, we need to block the threads for some time. We need to block the threads for some time so that there will not be a competition for other processes. Okay, there will not be competition for other threads. Understood why we need to block the threads? Understood? So, we need to block the threads based on requirement. Okay. So, how we can send a thread from active to block state means, understood everybody? Why we need to block the threads? And how we can block the threads means, from runnable place, we can send a thread to a blocked state. You can send a thread to blocked state. Okay? Using different ways. One of the ways to send a thread to blocked state is sleep. Okay, the sleep method takes one argument is an integer, and that integer represents the number of milliseconds. The integer represents the number of milliseconds that we need to block the thread. Number of milliseconds for which the thread is supposed to be blocked. Represents the number of milliseconds for which the thread is supposed to be blocked. So, let's consider like I have given the sleep time as 100. So, after 100 milliseconds, automatically the thread will be reactivated. When the thread will be reactivated means automatically after the sleep time is completed. Automatically after the sleep time is completed, the thread will be reactivated. After the sleep time is completed, automatically the thread will be reactivated. So, how we can send a thread from active to blocked state is one of the approaches using sleep. Sleep by giving some integer value. That is the sleep time. Once the sleep time is completed, automatically a thread will be returned back from blocked to active state. Let's consider for the same IRC and SIC thing. We are using sleep of some 1000 milliseconds. But can we expect the ICICI to give a response in 1000 or 2000? It may take 1000, it may take 500, or it may take 10,000. But can we analyze or can we expect the exact time in which ICSA will give the response? No. Just because it depends how we give username and password. If we give 10 times a wrong username and a wrong password, the result takes 5 minutes. So we cannot guess, okay, how much time it will take to get the response from this. So is it time-based approach valid in that scenario? In this scenario, is the time-based approach valid? No, right? So we need to go for some process or some code-based deactivation or reactivation of threads. Okay, the blocking or reactivation of threads. In general, it will be some process based or some code based. Okay? But in this specific scenario, definitely it should be some code based. If you make it time based, what happens? Okay? When the time is completed, again it will be reactive, which is not correct. Just because we cannot expect in a timely manner. We cannot expect the response from ICSA in a timely manner. So, if we expect that, yes, this process will be completed in 1000 seconds, then we go for time. Okay? If we expect, there will be some processes. Like there is a crowd of applications, we have some 1000 minutes to execute. So, we can guess that like 1000 seconds, definitely will be completed. But if we have dependency on another system, we cannot expect that it should give a response in 1000 or 2000 milliseconds. So, in that scenario, what we do is, we go for a code-based approach. Okay? Blocking a thread or reactivating a thread can be done either based on the time or based on the code. We can go with any of the approaches based on the requirement. So, based on the time means we can go for sleep with. Okay? Sleep with the sleep time which is milliseconds. Okay? Based on the code, if you want to go for a code-based approach, then we can go for method named suspend. Suspend is a method which is used to, you will not suspend, which is wrong. Suspend is a method which is used to send threads from active to block. To get back a thread from block to active, we use resume. Resume method is used to reactivate the thread. To reactivate the thread which is suspended, we use resume method. Resume method can be used to reactivate the thread, but it's not advisable to go with suspend and resume methods, just because the suspend and resume methods are deprecated methods. Deprecated methods is shown in this, like this. Okay? Deprecated methods. What are deprecated methods? Deprecated. Suspend and resume are deprecated methods. What are deprecated methods means? The methods that are present in earlier versions of JDK. The methods that are present in earlier versions of JDK, but while enhancing the JDK, the developer came to know that these methods are not giving correct results. Let's select I have one. Okay, I have the version 1.1. While developing 1.2 version, the developers came to know that some methods are not giving correct results. What they do is they will not remove the methods from the Java software, just because the methods might be used in other softwares. See, I have developed a method which is suspend. If I remove the suspend from my class, what happens? See, if I am the developer of Java software, I am the developer of Java software. I have developed some suspend method and that method is used to block the thread. And multiple applications will be using the suspend method. But suddenly in the second version, if I remove the suspend method, what happens? All applications will fail the compilation. So, considering that what Java people will do means, if they found that some method is not giving direct results, they will mark the method as deprecated. So that while compiling it produces a warning. Okay, warning will not close the application, but warning lets you know that there is a problem. Okay, so they just make the method as deprecated, and deprecated methods will produce a warning. Okay, while time of compilation. So by making a method as deprecated, they tell that this method is not giving correct results. Please don't use it. Okay, so we should not use deprecated methods. So we in general want to suspend and rescue methods, but they can be used. Okay, so to overcome the deprecation of suspend and rescue, we have wait method, which is used to send a thread from active to block and notify method and notify all. These two methods are used to send a thread back to active state. Wait method is used to send a thread from active to block. Notify all is used to send a thread from block to active. Notify and notify all will be used to send threads from block to active state. Okay. Now, in which class is wait notify methods today? Object. We told that object class they have wait notify analyze. We'll discuss them particularly. Another way has come. Wait, why wait is used to send a thread from active to block. Notify and notify all. These two methods will be used to send a thread from block to active. And how we can use wait, how we can use notify all, what is the difference between notify and notify all, that we will discuss when the time comes. In multiple things. Okay? But make it not like make is used to send a thread from active to block, notify and notify all is used to send a thread from block to active. How and when we can use them, that we will discuss in this. Okay? And last phase in multi-threading is depth. Depth. By default, a thread will reach the dead space when the task of the thread is completed. When the task of the thread is completed, then the thread will come to dead space by default. When the task of the thread is completed, then the thread will reach the dead space. When the task is completed, then when the task of the thread is completed, then the thread will go to death phase by default. That means it's natural killing of a thread. But sometimes we may need to forcefully kill a thread. Okay? It's a natural death, right? When a task of the thread is completed, if a thread is removed, means it is a natural death. But when the task is in progress, if we want to kill the thread, okay, we need to do something. What we can do, if we want to bring a thread to that state, means we can execute stop method. Stop method is executed. Bring a thread from any phase to that phase. But still, stop method is a deprecation method. Stop method is a deprecation method. Still, the stop method is a deprecation method. So, we go for another approach to kill a thread where we can nullify the thread object. If you nullify the thread object, then also the thread will be forcefully killed. And since stop method is deprecated, we go for the second approach, nullifying the thread object. Let's consider that a thread T2 is there in the running phase. Okay, thread T2 is there in the running phase, and still it has 100 milliseconds of CPU. 100 milliseconds of CPU. Okay, the thread will not come back to the running phase until the CPU time is completed. But there is an urgent and very important high priority task to perform. So the task cannot wait for 100 milliseconds. So what in general, in some scenarios, in some special scenarios, what we do is, in such cases, if some highly prioritized task will be executed, okay, in such kind of scenarios, what we do is, we forcefully bring a thread back to the runnable phase, even though the execution is not completed. Even though the CPU time is not completed, we forcefully bring a thread back to the runnable phase from running phase. Okay? In order to do that, we execute a method yield. Yield method is used to bring a thread forcefully from running to runnable phase. Yield method is used to bring a thread forcefully from running to runnable phase. Rest of the phases which I said last second, just let me explain again briefly. The first is newborn, second is active, drop, and death phase. These are the four stages in life cycle. Whenever you create a thread, it will be in newborn state, and in the newborn state, the thread will not have any threading features. The thread will get threading features only when the thread is activated. How we can activate a thread means by using the start method. Once the start method is executed, then the thread will be activated and will come in the runnable phase. Okay? And the thread will be sent from runnable phase to running phase based on the priority. Highly prioritized threads will be sent first to the running phase. But okay, how much time the thread will be there in the running phase means depends upon the CPU time. The CPU time assigned to the thread while training the thread. Okay, for each and every thread, the JVM will assign some CPU time, and the thread will be there in the running phase for that CPU time, and the remaining threads will be waiting in the running phase. And next, prioritized thread will go to the next iteration. So it will be a cyclic process. And the thread will be transferred from running phase to running phase when it gets expired. The thread will be transferred from running phase to running phase, okay, when the CPU time is completed. But if you want to forcefully move a thread from running phase to running phase, then we execute easily. Okay, and unused threads for the temporarily unused threads will be used in the block phase. Instead of thread from active phase to block phase, we can have a time-based approach or code-based approach. If you want to go for a time-based approach, then we go for sleep method, which takes integer value the number of milliseconds. After number of milliseconds, after the sleep time, automatically the thread will be reactivated. Okay, but if you want to go for code-based approach, either we can go for suspend or wait. But suspend is electricity result, so we go for wait. Go for suspend, we should go for result. If you go for wait, we can go either for notify or notify, or to bring back the thread from log to active phase. And we can send a thread to registers from many other places. Okay, just by either executing stop or modifying the thread. But the execution of stop is limited, so in general, to kill a thread, we modify the thread. Understood? This is the thread cycle, and we discuss different aspects of the thread cycle in a programmatic manner from tomorrow. Okay?